this is Olivia, back at it again with the Prepaze Scientific Notation series. This is episode 2, and today we'll be going over adding and subtracting numbers in scientific notation. So, last episode we talked about measuring the Bacillus anthracis bacterium, and we approximated that it was around 3 micrometers or 0.003 millimeters. Now, for our practice today, we're going to pretend that we're lining up 2 different bacteriums of Bacillus anthracis, and we're lining them up, and we want to see how long they are once we line them up together, and we're going to measure that length. However, you'll notice the scientific notation is presented a little bit differently between the two. For our pink bacterium, we're multiplied by 10 to the negative 1, and for our blue bacterium, we're multiplied by 10 to the negative 2. How do we add these numbers? Well, let me show you something real quick. So when we are multiplying each of our bacteriums by these powers of 10, what we're actually doing is multiplying by a fraction. And what's our standard when we are adding and subtracting fractions together? Well, we need to find that common denominator. And that's exactly what we're going to do in terms of scientific notation. So we have 10 to the negative 1 is equal to 1/10, so 1.2 is being divided by 10. We have 10 to the negative second equaling 1 over 100. So when we multiply 7.1 times 10 to the negative 2, we're dividing by 100. So let's divide by the same number. I think what's going to be easiest for us is if we pick the larger denominator so that we're scaling up our numerator with it. So let's pick 10 to the negative 2. Our blue bacterium is already represented multiplied by 10 to the negative second. So we need to change how 1.2 is represented in our scientific notation so that when we multiply it by 10 to the negative second, we are still representing the same quantity, the same length for our pink bacterium. So originally, we had 1.2 times 10 to the negative first. 10 to the negative first means we move 1 decimal place in the left direction. So really, the quantity of our pink bacterium, how long it is 0.12 millimeters. This is our value that we're representing through scientific notation. But we want to represent this value with 10 to the negative second. So I'm going to multiply some value and then move the decimal places 2 spots over to the left to get 0.12 again. Well, in order to undo that, I am going to move 2 decimal places to the right to figure out what value I'm presenting and multiplying by 10 to the negative second. So 0.12 is the same thing as 12 times 10 to the negative second. Now we're dealing with a like denominator. We've got 12 times 10 to the negative second, or divided by 100, plus 7.1 times 10 to the negative 12, or 7.1 divided by 100. We have a common denominator. Now we can now we can add our numerators. This also works the same way with subtraction. Once we have our scientific notation being raised to the same power, we can add our first pieces together. So we're going to add what is the equivalent of our numerators in this scenario. 12 plus 7.1 gives us the value of 19.1, still multiplied by 10 to the negative second, or maintaining that same denominator, just like when we add or subtract fractions. But this violates our scientific notation rules. Recall that our scientific notation rules say we have to pick a representative number between 1 and 9.9. It's got to be one digit, a ones digit, and then we can have some decimals. So 19.1 is a 2-digit number followed by some decimals. So how do we pick a representative number that represents 19.1, but it's in between 1 and 9.9? We're going to shift that decimal place 1 over to the right and make the value 1.91. However, once we make that shift, what is our exponent going to be? We were moving 2 units over to the left times 10 to the negative second, but now we've compromised how many times that we're moving. So let's check what our exponent should be. 19.1 times 10 to the second is moving our decimal place over twice in the left direction. So our value is 0.191 millimeters. What do we do to 0.191 to get 1.91? We moved our decimal place once over in the right direction. So to go from 1.91 to 0.191, we have to move 1 over in the left to create 10 to the negative first. See you in the next video.